Alright, so welcome to the video for lesson number 2 in geometry. So this lesson is going to be about a different way that we can prove two triangles are congruent. So in lesson number 1, we showed that side, side, side is a possibility for us proving two triangles are congruent. We also learned about the reflexive property, and we learned what to do when we see the word midpoint and bisects. In lesson number 2, we're going to look at another thing that we can see or visualize in our pictures or diagrams. We're going to learn about Sideangleside, and we might even see a couple more rules that we can use within our proofs. Because this video is teaching you a lesson, make sure that you stop it or pause it, rewind it if you even need to make sure that you're actually understanding what's going on here. Don't just go through and fast forward to write down everything that I'm writing down. That's not really going to help you here. If you totally got this and you're like, this is good, I understand what's going on, all right, that's when you can kind of let it kind of just play and kind of do some stuff on your own. All right, so let's first take a look at the opening exercise. So it says, look at the diagram below and look for one set of segments that are congruent. That's actually a typo. That's actually supposed to say angles. Now, it looks like there are some angles that are congruent here, but there's one in particular that we know for sure are congruent, and that are these two angles here and here. I know those two angles are congruent because we would call those vertical angles. One of the things that we talked about way back in unit number 1 is that when you have two lines that intersect each other where the angles are across from each other are called vertical angles, and they're congruent. Now, if you remember, to label or name an angle, we use an angle symbol and 3 letters. So this angle would be K, L, J. I'm going to say it's congruent to angle MLN. And the reason we knew that was because vertical angles are congruent. And you'll notice that rule is right on that first page or 2 pages of rules in your packets. And it says, remember to look for those 2 things. So in this lesson, we're going to look for vertical angles. And from lesson 1, we're going to keep looking for the reflexive property in every diagram before beginning our proof. So in the previous lesson, we learned that side, side, side is an appropriate way of proving triangle congruence. Well, there are other ones as well. So in today's lesson, we're going to learn about side, angle, side. So now we're finally talking about an angle. So this works when two triangles are congruent, and it tells us that there are 2 sets of corresponding sides that are congruent and 1 set of included angles. What I mean by included angles is the angle that's in between the 2 sets of congruent sides. So if I look at example 1 here for a minute, it tells us that we are looking for the missing piece of information that would allow us to prove that these 2 triangles are congruent by side, angle, side. These are not proofs. These are just us trying to find some information. So to find side, angle, side, the only side that I can label in triangle ABC would be side AC, because that would give us our side, our angle, and our side situation. See how the angle's in between the 2 congruent sides? The other side I would be looking at would be L and J. So to use side, angle, side, I would have to know that AC is congruent to JL. In example 2, we have to use something we learned way back in lesson number 1. So we see that QS is reflexive, so that's a congruent set of sides. Now, if you're having trouble visualizing this, take a look at the triangles separate. So if I have triangle RQS, I have this labeled and I have this labeled. If I wanted to use side, angle, side, I would need that angle where angle Q is, the angle in between. So that would be this angle here. Think about where that angle would be in the other triangle for a second. Good, so it would be right over here where the S is. Now, in labeling those triangles, remember, use 3 letters. So I'd say angle RQS is congruent to angle DSQ. All right, so now that we understand what side, angle, side is and how we can kind of see that in our proof, let's try a proof. So in this picture, it says that MN is congruent to ON, given, Angle MNL is congruent to angle ONL, given. And in my picture, I see the reflexive property. So I could start by saying MN is congruent to ON, and that was just given. That's one circle. I can say that angle MNL is congruent to angle ONL, also given. I can say that LN is congruent to LN by the reflexive property of congruence. And then all of that tells us that triangle MNL is congruent to triangle ONL. But this time we don't want to say side, 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 because I don't have 3 sets of sides. I have 2 sets of sides and an included angle. So I'm going to say side, angle, side. This was a side, this was an angle, and that was a side. The rigid motion that would map one triangle onto the other in this case would be a reflection over the line in the middle, so LN. All right, let's take a look at 3. 3 tells us that SU bisects TR and TR bisects SU. So both of these diagonals that are drawn in our parallelogram here are getting cut in half. So if SU gets cut in half, I know SV and VU are the same. I know if TR gets cut in half, I know TV and VR are the same. Now in this picture, I see a couple different triangles. So I don't want to look at any 2 of them. Whoops, I don't know what I'm doing here. Let's fix this. I was trying to use highlighter, but I guess that's not working. So let's just use pen. So if I look at triangle SVR, there's my highlighter, and triangle UVT, I'm just looking at those 2 triangles. Now in those 2 triangles I have 2 sets of congruent sides, but I don't have the 3rd set and I don't have an angle. So I'd have to look for something else in my picture. So what I see is these intersecting lines which give us these vertical angles in the middle. So let's start writing some stuff down. So the first thing I want to write is my given. So I have to write SU and TR bisect each other. That's given. And that one given tells us 2 things. It tells us that SV is congruent to VU because a bisector divides a segment into 2 congruent segments. And it also tells me that RV is congruent to TV by the same reason. So I can say a bisector divides a segment into 2 congruent segments. That's 2 sets of sides right there. The last thing I was able to state was that the 2 angles in the middle were congruent. So I can say that angle SVR is congruent to angle UVT because of vertical angles. So now I know that those 3 pieces of information tell us that triangle SVR is congruent to triangle UVT by side angle side. this was a set of sides, this was a set of sides, and this was a set of angles. Now, the rigid motion that would map this triangle onto the other is not a reflection. If I was to reflect, the corresponding angles wouldn't match up. But I do know that I can rotate 180 degrees about point B. Remember, you have to tell me what point you're rotating about. If you just say rotate 180, it could be anywhere. So what's new in this is we're using bisect twice, and we're using vertical angles in our proof. Let's see another one. So here we go, another new reason here. So perpendicular. Perpendicular makes 90-degree angles. So I know where GH and HG intersect is going to be a 90-degree angle. I know where IH and HG intersect is going to be a 90-degree angle. There's a typo there. That should say GJ and JI. This should say JI. That 90-degree angle should be down here. So let's fix that. Okay. It then tells us that GH is congruent to IJ and JG is congruent to HI. Now, right now, without looking at anything else, I can say those two triangles are congruent because of side angle side. If I chose to ignore the 90-degree angle part, I could make the reflexive property in the middle and say side, side, side. So there's actually two completely different ways of doing this proof. So if you and your partner chose to do it differently, the answer is going to look totally different. All of your reasons for the most part are going to look totally different. But guess what? You're both going to get full credit. Now, because we're talking about new stuff, let's talk about what perpendicular means. So I'm actually not going to use reflexive here because I want to use those 90-degree angles. So there are two things we know about perpendicular. Number one is perpendicular lines create or form right angles. And we also know that anytime I see two right angles, they have to be the same size because they're the same value. So essentially, whenever we see perpendicular, we actually have two steps. So I'm going to say JG is perpendicular to IJ. Remember, we had to make that correction. And I'm going to say IH is perpendicular to HG. Now, they were both given. Now, because of this, I know that angle GHI and angle IJG are right angles. I know that because perpendicular lines form right angles. Now notice I have not yet said that they are congruent to each other. So now I have to say angle GHI is congruent to angle IJG because all right angles are congruent. The next two pieces of information I have are HGH is congruent to IJ. That was given. And JG is congruent to HI. Again, given. Then I can say that these two triangles are congruent by JGI and IHG because of side angle side. I have two sides here, and I have my angles here. The next thing says, in today's lesson, we learned two new proofs, statements, and reasons. So I know about perpendicular lines now, and I know about vertical angles now. What I'm going to ask you to do is take a minute and look back at your notes and see what do we know about them. You could even look at your proof statement sheet and see kind of what do we know about those. So take a minute to do that. You could even pause the video to do this. Good. So hopefully you wrote something down here, because I want you to actually think for yourself, not just write everything down that I'm saying. And I'm going to put some things that I notice about these two rules. So whenever I see perpendicular, remember the symbol is the upside down T. And I know it's always going to be 2 steps in my proof. I also know I'm going to first state the angles are right. Then I'm going to second state they're congruent to each other. Vertical angles I'm always going to look for in the diagram. These are not going to be given to me, right? I have to actually look for them in the diagram. I can't just say, oh yeah, it'll probably be given. Also, I'm looking for intersecting lines. Sorry, my handwriting's getting worse. All right. So from there, we have some homework assignments to look at, right? There's a couple questions here for us to try. I would like for you to pause the video at this point, try these 3 by yourself, even look back at your notes if you have to, then turn back on the video to see if you actually did them correctly or not. All right, so welcome back to the video. Hopefully you took some time to try these on your own. It's important for you to try them on your own. Don't just let the video keep playing here. So it says, in order to use side angle side to prove these triangles are congruent, draw in the missing labels. So the angle would have to go in between the congruent sides. So I'd have to have angle A congruent to angle D. For B, I'd have to have another segment. So I'd have to have AB be congruent to DE. Number 2 is an actual proof. This actually wasn't a terrible one because they gave us a lot of info. So it says that BC and DC are congruent, angle 1 and angle 2 are congruent, and I see AC is reflexive. So I can use my givens. Angle 1 is congruent to angle 2. That's given. I can say BC is congruent to DC. That's given. 2 pieces of info. Then I can say AC is congruent to AC by the reflexive property of congruence. Then I can say that the 2 triangles ABC and ADC are congruent by side angle side. I have an angle, I have a side, and I have a side. What rigid motions would reflect one onto the other? This would be a reflection over AC. Number 3 is almost identical to one of the ones that we did in class, which would be number 3. But it's a different kind of picture here. So it says they bisect each other. So I know that KM and LM are the same. LM and JL are the same. Also, I see vertical angles here. So let's state everything I know. I know that KL, well, actually first we have to say KM and JN bisect each other. That's given. I know that tells us 2 things. It tells us that KL is congruent to LM, and it tells us that JL is congruent to NL. Notice I'm putting these in the same statement because I don't want to have to write the same thing twice like I did back here. Right? So remember how I did this twice? Well, I'm only going to do it once, which I could totally do. So I'm going to say a bisector divides a segment into 2 congruent segments. Also, I know that angle KLJ is congruent to angle MLN by vertical angles. I see those intersecting lines. I know that's going to be true. Therefore, I know that triangle JKL is congruent to triangle NML because of side angle side. I have my angles here, and I have my two sides here. How would I map that one triangle onto the other? I would rotate 180 degrees about L. Hopefully this video helps. If you're done with this video in 20 minutes, that means you did not do it appropriately. All right? You really should be trying these on your own. All right? Because remember, on a quiz or test, you're going to have to try this on your own. Also, if you watch the video all the way to the end, I'm going to give you a hint. Tomorrow, even though I'm not there, you're still going to have a quick quiz on one of these proofs. So make sure you're looking over your rules and start studying. Remember, you should be studying every single day. Hopefully you don't miss me too much. See you on Monday.